Hello everyone, welcome to IIT-JAM in Chemistry tutorial number 52, and this is lecture number 9 of the Physical Chemistry chapter Solid State. The subtopic of this lecture number 9 is close packing in metals and metal compounds. In the third part of this lecture number 9, we are going to discuss zinc blende or sphalerite or blackjack and Wurtzite. So let's start with sphalerite, and also sphalerite is known as zinc blende or blackjack. This is actually the chalcogen ore of zinc, which is actually zinc sulfide. And zinc sulfide has two structures. One is zinc blende, another one is Wurtzite. So first of all, we are going to discuss zinc blende. And from the radius ratio, which is 0.40 of zinc blende, it belongs to the that of tetrahedral arrangement, which has the range 0.225 to 0.414. Therefore, its nature is tetrahedral and the coordination arrangement is 4 is to 4. And here the zinc cations form the cubic close packed structure. That means the face centered cubic structure. Here look, the black spots are actually zinc 2 plus ions which form the FCC lattice. So you can see 14 number of zinc atoms, out of which 4 are inside and 10 are outside. And within it has 8 tetrahedral holes, and in each alternate tetrahedral hole the sulfide ions are being occupied. So the stoichiometry ZNS is justified here, and the arrangement is 4 is to 4. So the sulfide ions alternately occupy the 4 out of 8 tetrahedral holes. And these tetrahedral holes are actually, if you divide this unit cell into 8 small cubelets, then in the body center of each alternate cublet, it will be occupied by the sulfide ions. And each small cublet looks like this. It looks exactly like a methane molecule, where this is instead of carbon, this is sulfide, and this black spots, that means these atoms or ions actually are in place of hydrogen in case of methane. So exactly the small cubelets look like methane, but all the cubelets are not do not look like this, because this small cublet has a body center occupied by sulfide, but next one is not occupied. This one is occupied, but next one is not occupied. So this way, here in this picture, the front right top cubelet, it is occupied, but the front left top cubelet is not occupied. This is the back left top, which is occupied. On the other hand, the right um, mm, back and top cubelet is unoccupied. So since the zinc 2 plus ions from the face centered cubic lattice, therefore there are 4 zinc 2 plus ions within the unit cell. So 4 zinc plus ions means the face centered cubic. Here you can see 14 number of black spots, that is zinc ions cation. But out of these 14, 4 are inside, and we know the calculation and we can get it from our previous lectures, and 10 are outside. Now here this sulfide ions are within the body. So since they are within the body, so their contribution should be 1 for each. So 1 plus 1 plus 1 plus 1, 4 are inside. So 4 zinc and 4 sulfides, making it a 4 is to 4. Actually, making the fact that they have 4 formula units within one unit cell. Okay, and 4 is to 4 arrangement, actually, this is surrounded by 4 nearest neighbors. On the other hand, alternately, this is also surrounded by 4 nearest neighbors. Okay, zinc is surrounded by sulfide, 4 sulfide, and sulfide is surrounded by 4 zinc. So since the sulfide ions occupy 4 out of 8 tetrahedral holes, then all of them will remain inside the unit cell. Therefore, there are 4 formula units in one unit cell of zinc blende. Now, ZNS, other than ZNS, what type of other compounds also adopt this crystal structure? So these compounds are actually zinc selenite, cuprous chloride, cuprous iodide, mercuric sulfide, beryllium sulfide, cadmium telluride, aluminium phosphide, gallium phosphide, tin antimonide, silicon carbide, and ferrous sulfide, etc. So that's all about the crystal structure of zinc blende. Now, Wurtzite. So zinc blende and Wurtzite are polymorphs of zinc sulfide, ZnS. So like zinc blende, Wurtzite also has radius ratio 0.40. And definitely it has 4 to 4 type of coordination and tetrahedral, it is tetrahedral in nature, but the unit cell is hexagonal. The unit cell of zinc blende was face-centered cubic, but this is hexagonal. Okay, that one was cubic and this is hexagonal. And this is simple, that means primitive. The zinc ions form the primitive space lattice. And here, in if you divide this into two trigonal prisms, then within the body there is yet another zinc in the middle of the prism. And this zinc is tetrahedrali surrounded by four nearest sulfides. On the other hand, this sulfide is also surrounded tetrahedrali by four nearest zinc 2 plus ions. Here, the zinc ions form the hexagonal close packed lattice, and the sulfide ions occupy each alternate tetrahedral hole, and vice versa. Not only zinc, but sulfides are also occupying the tetrahedral holes. So there is some difference. In the cubic structure of zinc blende, all the cell parameters are 90-degree. That means alpha equal to beta equal to gamma equal to 90-degree and A equal to B equal to C. But here, A equals to B not equal to C. Alpha equals to beta equals to 90-degree, but gamma equals to 120-degree. So this is the difference. And this type of structure is adopted by zinc oxide, beryllium oxide, zinc sulfide, aluminum nitride, cadmium selenide, and ammonium fluoride. Now, if one of the three unit cells forming the hexagonal unit is separated, then it has the look. Like this is the structure here. Actually, this is the hexagonal unit which is made up of three unit cells. So if you just extract one of them and eliminate two of them, then it should have the look like this. So this is exactly one unit cell of Wurtzite structure, where this sulfide is surrounded by 4 zinc and this zinc is surrounded by 4 sulfide. And this is the trigonal prism. This is the trigonal prism, that is half of this unit cell. And within its body, not exactly in the middle, but in some position within the body, this sulfide is present, as well as the zinc is also present. Now, if you go to calculate the number of units within within this unit cell, then the calculation should be like this: number of zinc cations per unit cell. We have to calculate this. One is within the body, so this is within the body, this violet one. You can see here 5 number of zinc ions, 5 violet spots. So this one, 2, 3, 4, and 5. Okay. Out of this, one is inside. Now, where are these situated? There are 4 more zinc ions, out of which this one is 100. This one is 60-degree edge. This one is 60-degree edge. Whereas this one is 120-degree edge, and this one is also 120-degree edge. Okay. So in the 120-degree edge, there are 2 zinc cations, and in the 60-degree edge, there are also 2 zinc cations. Now, you know that this one, this complete ion is not completely within the unit cell. Its 1/3 part is within the unit cell, and 2/3 is outside the unit cell in the 120-degree edge. Whereas in case of 60-degree edge, 1/6 is inside and 5/6 part is outside. So the calculation should be like this: 2 into 1/3 from the 120-degree edge and 2 into 1/6 from the 60-degree edge. And what is the overall calculation? The summation should be 2. Now let us calculate the sulfide ions. Okay, one is within the body. Okay, within the body, but you can see here 9 sulfide ions, and out of this 9, one is completely within the body. So one from the unit cell. Now these are the apices or vertices. Okay, out of these vertices, total 8 vertices are here. 1, 2, 3, and 4. These 4 ions are actually in the 120-degree vertex. And these 4, 1, 2, 3, and 4, they are in the 60-degree vertex. Then 120-degree vertex, these atoms are actually inside the unit cell by 1 sixth amount, and 5 by 6th part is outside the unit cell. Whereas here 1 by 12th part is inside in the 60-degree vertex and 11 by 12th part is outside. So what is the number of this 1 by 12? Is 1, 2, 3, and 4. As well as this number is also 4, which is 1/6 inside. So let us calculate. 1 within the body, 4 by 1 by 12th part, and 4 other by 1 by 6th part. What is the total? The total is again 2. So it satisfied the stoichiometry, and you can see here 2 formula units. That means 2 zinc and 2 sulfide. That means 2 formula units are within 1 unit cell. And if 2 are within 1 unit cell, then combination of 3, that is within the 1 hexagonal unit, there are overall 6 molecules or 6 formula units of zinc sulfide. Okay, so we can conclude there are 2 formula units per unit cell and 6 formula units per hexagonal unit. So that's all about the structure of zinc blende and Wurtzite. Thank you and have a nice day.